Section 2.5 is all about zeros of polynomial functions. We're going to do some things we've done in the past. We're also going to expand on it a little bit. So we've got all the pieces we need to begin solving. We've been able to factor, we've been able to use various techniques like inverse operations, which we should probably write down. So the biggest tools again are factoring, or I'm going to use the GCF, greatest common factor. Don't forget about that. That's one thing we often do forget about. So greatest common factor and or just normal factoring. And then some other things we've been using are inverse operations. For an example, we've been using a square root. If we have like x squared or y squared, we've been using a square root in order to solve. So the fundamental theorem of algebra says if f of x is a polynomial of degree n and n is greater than 0, then f has at least one 0 in the complex number system. In fact, it's going to have at least 1 0 means it's probably going to have 2 or more depending on the function. So we're going to work on linear factorization to figure out how many zeros we can find. So f of x equals, or if f of x is a polynomial of degree n and n is greater than 0, then it has exactly n factors. So it could be f of x equals some subscript or some coefficient a sub n, then you have a bunch of linear factors. X minus c sub 1, where c is just a constant, times x minus c sub 2, times x minus, et cetera, where all those c values are just complex numbers, some constant complex number. So down at the bottom here, we're going to start off pretty simple. We're asked to find the zeros of each function. In general, when you're finding the zeros of a function, you're just going to set the function equal to 0 and solve. So in order to solve x minus 2 equal to 0, we're going to add 2 to both sides, and we get x equals 2. Now, going back to how many zeros this should have, it's x to the first. This is a degree 1. It has exactly 1 0. For b, we got x squared minus 6x plus 9. It's x squared, so we should have 2 zeros, potentially. We'll talk about what I mean by potentially in a second. So we're going to factor x squared minus 6x plus 9. We're going to break it down into x plus blank, x plus blank. So we got to think of two numbers that multiply to positive 9 and add to negative 6. So it'll be x minus 3 times x minus 3. Now if we set the first one equal to 0, we end up with x minus 3 equals 0. We solve for x and we end up with x equals 3. If we set the other one equal to 0, x minus 3 equals 0, I feel like we just did it. We get x equals 3. Let me shift this a little bit. So either way we do it, we get x equals 3. So really, we only get one unique 0, but sometimes you'll hear it referred to as a double root or a double 0. It's used twice. It shows up in two separate factors. For these next two, we've got a little bit more work to do. So f of x equals x to the third plus 4x. The first thing we should take a look at is we've only got two terms here, both of which include an x. So let's factor out an x from both of those. And when we factor out an x out of x cubed, we're left with x squared. And when we factor out an x from x to the, or 4x, we end up with just 4. Now we're finding the zeros of this. So we're looking to see what is going to make this equal to 0. Well, we've got two things. We got this times this equal to 0. Remember, going off of the zero product property, that means either this first thing has to be equal to 0 or the second group has to be equal to 0. Now I'll go ahead and solve x equals 0 for you because it's already done. You're welcome. But we need to solve x squared plus 4 equal to 0. To solve that, we got to do our inverse operations. We subtract a 4. We get x squared equals negative 4. Now we're going to take the square root of both sides using that inverse operation again, and we end up with just x on the left side, and on the right side we're going to get plus or minus 2i. Remember, taking the square root of a negative number is always going to result in an I. So looking at this, our degree we started off with is 3, and we have 3 zeros, one of which is 0, another one is positive 2i, and another is negative 2i. Now letter D is x to the fourth minus 1, which means we should have 4 zeros, even if some of the zeros are repeats. So x to the fourth minus 1, this one's going to be a little goofy because we got to factor it. And it's factorable into x squared plus 1 times x squared minus 1. It's kind of like that difference of squares that we saw in the past, but this is like difference of quartics. So we have two of these situations that we need to set equal to 0. So we have x squared plus 1 equals 0 and x squared minus 1 equals 0. To solve for the one on the left, we're going to subtract 1 on both sides. We get x squared equals negative 1. And then when we take the square root of both sides, we get x equals, well, the square root of negative 1 is I. But since we put the square root in there, we're just going to get plus or minus I. So there's 2 of our 4 zeros already. Next up, on the other side, we'll add 1 to both sides. We get x squared equals 1. We're going to take the square root of both sides. And we end up with x equals plus or minus 1. So our options are, sorry, I didn't realize that was off screen. Our options are positive 1, negative 1, positive I, and negative I.